And this, as your math teacher, is where I'm going to admit that this section is kind of just one of those unique sections in math that I don't remember using a lot more outside of pre-calculus, but we're going to do it so everybody knows how to do this, so that if you do go on to a calculus course or some other course in college and they talk about dividing polynomials, then you've seen it before. So that's kind of where I'm coming from, okay? I can't tell you that there's like this application that we're going to do later in a different chapter where you're going to do this specifically. But like I said, I do want to make sure that we cover it so that you've had some exposure to it, you've seen it. And if for some reason in a different class down the road that you need to use it, you feel comfortable with that. Does that explanation make sense? So basically it's kind of a weird little section. You'll be able to do it, and then we'll kind of move on from there. So kind of a standalone little thing. So there's a bunch of notes on this at the beginning. I will kind of pull out things from the notes as we go. So what I mean by that is there's this thing that's called the division algorithm. So basically the division algorithm says that you can divide one polynomial by another polynomial and have a remainder. So this is just like dividing. You can divide, a number by another number. You can divide 10 by 4, right? If you divide 10 by 4, that's 2 with a remainder of 2. Or if you divide 9 by 4, that's 2 with a remainder of 1. So we can do that with numbers, but we can also do it with polynomials. Yay! Right? So we're going to talk about how we divide polynomials, and we do that using long division. Bust out your long division skills, right? And then there's also this little technique called synthetic division that we can use, and then we can have a remainder. So just kind of stick with me. I think it'll make sense as we go through it. This is just kind of a very example heavy section where I show you what we're going to do. You're going to practice it, and then it's kind of something you can stick in the back of your math knowledge and be able to pull out if we have some applications in the future. Okay. All right. So in exercises 1 through 14, use long division to divide. So you can see example number 2 says that we have 5x squared minus 17x minus 12, and we want to divide that by x minus 4. We want to be able to divide that by x minus 4. And so we're going to do that using long division. All right. So long division, if you remember, looks something like this. Okay. We put what we're dividing into underneath. Oh, I forget what the name of this bar is, but say this is 5x squared minus 17x minus 12. Hi, Greta. We are doing section 2.3. It's kind of a unique little section. Let's just call it that. Okay. So to set up our problem, if we're going to divide one polynomial by the other, we're going to put what we're dividing inside of our, I forget what that's called, division bracket. I don't even know. I don't even teach long division in algebra or up, so my terms are off here. You're going to basically set it up like this, just like you would set up a regular division problem. Okay. The first thing that you're going to do is you're going to try to figure out how to get rid of, what do you need to multiply by to get rid of this first term? Okay. So you're basically trying to clear off term by term, starting with the highest order that you can. So I want this. I have 5x squared. I want whatever I multiply this by to give me a negative 5x squared so that I get rid of my x squared terms. So what do I multiply x by to get 5x squared? Well, to multiply something times x to get negative 5x squared, I need to multiply it by negative 5x, right? So negative 5x times x gives me negative 5x squared. Now, when I write that into my long division problem, I'm going to put it over top of the same order. So see how this is just a x and this is just an x. So I'm going to put negative 5x over top of there. Oh, I'm doing this wrong in my head. Sorry. I don't need this to be negative because when you do long division, you subtract. I'm thinking algebra, right? So if I multiply 5x times x, then I get 5x squared, right? But then I also have to multiply 5x by negative 4. So 5x times negative 4 is negative 20x. Okay. Now, if I remember how to do long division, right? Right. I'm going to subtract all of these from the one above. That's what I was doing wrong. So 5x squared minus 5x squared is nothing, right? Negative 17x minus negative 20x is actually just like negative 17x plus 20x. So it's 3x, right? And then I pull down my next term, which is minus 12. So now I need to figure out how am I going to get rid of 3x by multiplying by x. So I'm going to multiply by 3. Okay, so 3 times x is 3x. 3 times negative 4 is negative 12. And when I go to subtract those, I actually get no remainder. So that means that 5x squared minus 17x minus 12 divided by x minus 4 is 5x plus 3. Okay? Or another way we could say this is 5x plus 3 times x minus 4 equals 5x squared minus 17x minus 12. So who knew? Who knew that you could divide polynomials, right? Very exciting, right? So who wants to see another example? Who's like, what in the world is going on? All right, I'm going to do another example just to make sure you guys all got it. Actually, let's see. Yeah. There we go. Kind of erase that. Let's do number... Let's do number 10. Oh, that's not what I meant to do. Let's do number 10. So we have 1 plus 3x squared plus x to the 4th divided by 3 minus 2x plus x squared. Okay, so let's do some long division here. So we're going to set this up like a long division problem. Okay, and one of the things you want to do when you do a long division problem is you want to write the polynomial in order from greatest to least exponent. So you have x to the fourth, okay? We're going to write that first because that's our highest order. That's what we're going to try to get rid of. Also, we want to put in spaces for those exponents that we don't have values for. So 0x cubed. We don't have an x cubed, right? We have a 3x squared. We don't have an x, so we have 0x plus 1. Okay, so you'll see why that's important when we want to write out a division problem. So then we're dividing that by x squared minus 2x plus 3. Okay, so the first thing that we want to do is we want to get rid of our x to the fourth. So in order to get x squared equal to something that I can get rid of x to the fourth, I need to multiply by x squared. Okay, so I'm going to multiply every term here. So I have x squared times x squared, which is x to the fourth. Then I have x squared times negative 2x. So I have negative 2x cubed. And then I have plus 3x squared. So this is why I need to put my zeros in, because even though I don't have that in my original equation, when I do my long division, I might actually cancel one out. Okay, so now I'm going to subtract. X to the fourth minus x to the fourth is just 0. 0x to the third minus a negative 2x to the third is 2x to the third. And 3x squared minus 3x squared is nothing, right? So now I need to, so I'm just going to put nothing here. 0x squared plus 0x. So now I need to figure out how to get rid of 2x cubed. So over here, again, this is crazy looking. This should just say x squared. What do I need to multiply x squared by to get a 2x cubed? Well, I need to multiply by 2x, right? 2x times x squared gives me 2x cubed, all right? 2x times negative 2x gives me negative 4x squared, and 2x times 3 gives me 6x. So now when I subtract, I get, this is 0, right? 0x squared minus a negative 4x squared is 4x squared. Okay, 0x minus 6x is minus 6x. And then I'm going to bring down my 1. Okay, so now what do I need to multiply x squared with to get rid of 4x squared? I need to multiply by 4. Okay, so 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. And 4 times 3 is 12. Okay, so now I subtract, and I get 0, right? Negative 6 minus a negative 8 is going to give me positive 2x. And this is a 12. And then 1 minus 12 is going to give me negative 11. Okay. I can't do anything now. This is my remainder. Okay. So if I wanted to divide this, I could say that x squared minus 2x plus 3, right, times this up here, times x squared plus 2x plus 4 plus my remainder equals my original equation. All right, did I totally lose you guys? You guys were like, I was not expecting to log into this today. Everybody follow along with that math.
Yeah.
Yeah. It's fun, right? One word for it. All right, so the last piece of information is how do you write the remainder? So here I just kind of cheated and I said it's plus the remainder. But how do you actually write the remainder? Okay, so the remainder, you actually take whatever your remainder is, which was 2x minus 11, and then you need to put that over what you were dividing by. Minus 2x plus 3. So if you actually are writing this out, you would write this for the remainder. Okay. All right, so that is fun with using long division. So try those out. Let me know how they go. Definitely check your answers. Okay. And now we're going to learn yet another way to divide polynomials. So this is this picture right here. Okay. So say you had a polynomial that was ax to the third plus bx to the second plus cx plus d. And you're dividing it by x minus k. You can use this pattern to divide. So I'm going to explain it here and then we're going to do a lot of examples. Okay. So you draw this little box and you put the coefficients a, b, c, and d at the top. And then you put the k value, whatever you're subtracting by, out here. Okay. Then there's this little pattern. You bring down the a, and then you multiply that by k. Okay. And then you add together and multiply by k, add together, multiply by k, and whatever is left over is your remainder. So you guys can totally do that based off of my explanation, right? Not. All right, so let's try this. This is called synthetic division. Okay, so let's try synthetic division, which is a little bit different. Well, it's a lot different, I should say that, than long division. So it's another way to divide polynomials. We need a lot of paper for this one. All right, so we're going to do number 16. So this is how synthetic division works. Okay, it's kind of like a math trick is what you can think of synthetic division. So synthetic division looks like this. You make a box. Okay, inside your box, you're going to write the coefficients of your polynomial. Okay, so inside my box, I'm going to write 5 because that's the coefficient for 5x cubed. Then I'm going to write 18 because 18 is the coefficient for x squared. Then I'm going to write 7 because 7 is the coefficient for x. And I'm going to write -6. Okay, so those are my coefficients. I'm going to write those inside my box. Okay, then outside my box, I'm going to use this number. So if you look at the pattern, it says x minus some value k, and k goes over here. Well, I have x plus 3. So that means that my k value is -3. Okay. So this is what you're going to do. You're going to set up this box. Okay. And then you are going to do this. You're going to Follow this pattern. So first, you're going to pull down the first number. We like that, right? First number we pull down is 5. Now, we're going to come up here, okay? And we're going to take whatever number this was 5, and we're going to multiply it by our k value times -3. So what is 5 times -3? -15, right? Now, we're going to add up 18 plus -15, and we get 3. We're going to add 18 and -15, and we get 3. So we're going to take this over, and we're going to multiply 3 by our k value, which is -3. 3 times -3 is negative, sorry, I should write it down here, -9. Now we're going to add up again. So we have 7 plus -9, which is -2. Okay. Again, we're going to go diagonal. We're going to multiply -2 times -3, and we get 6. -6 plus 6 is 0. Okay. So now, since this started with an x cubed, we can come down here and say that this is going to be x squared plus x minus 2, and this is our remainder of 0. So if I divide 5x cubed plus 18x squared plus 7x minus 6 and divide it by x plus 3, the solution is 5x squared plus 3x minus 2. Okay. How does that feel? Weird? Has anybody ever seen anything like that before?
No, it makes sense now.
It makes sense. Do you guys want to see another one? Well, we'll do more, I guess is what I should say. We'll do some more. So, okay, I'm just looking at my paper, which one we want to do next. I think we'll skip 20 because we're going to stay on that. So in 15 through 23, when you do your homework, those you use this synthetic division, but your remainder you're not going to have a remainder. So that's nice, right? So then if we move to like number 36, it says use the remainder theorem and synthetic division to evaluate the function at the given value. Use a graphing utility to verify your results. Oh no, so you might actually have remainders. You might actually have remainders, and I shouldn't have said that. And 15 through 23. Let's talk about how to use this synthetic division with something called the remainder theorem to figure out what the value of the function is. Okay. So I want these guys right here. All right, so this is one of those things where I'm going to show you it's probably not what you're going to use on a regular basis. So if I gave you a problem, you didn't have the description at the top, right? If I just gave this problem, I said g of x equals 2x to the 6th power plus 3x to the fourth power minus x squared plus 3, and I wanted you to tell me what g of 2 is, right? How would you normally solve that? You would just put in, for number a, right? You would just put in x equals 2, and you would solve the polynomial. You would tell me what the value of that is. What they want to show you is that you can actually use synthetic division as another way to find what the value when g equals 2 is. Okay, so the way that we do it is the same way that we just did with the synthetic division. We're going to take the coefficients, right? The coefficients, and we're going to list them across the top. So the coefficient for x to the 6th power is 2, right? We don't have an x to the 5th power, but we actually have to put a placeholder in for x to the 5th power. For x to the 4th power, we have a coefficient of 3. X to the 3rd power, we don't have a coefficient. X to the 2nd power is -1. X, just x, we have no coefficient, so it's 0. And then we just have a constant of 3. Okay, so we would set it up like this. And since we're using synthetic division and we're not sure what we're dividing by, what we can do using something called the remainder theorem is if we want to solve for g of 2, what we do is we make our k value equal to, not 3, we make it equal to 2. Right, whatever is in here. So for example, if we were doing b, we would make our k value equal to 1. So now we're just going to do this process again. So you're going to get really used to doing this. So what you do, you pull down the first number, it's 2. Okay, then you take 2 and you multiply it by 2, your k value, 2 times 2, right? And you get 4. Then you add them together. 0 plus 4 is 4, right? Multiply 4 times 2 to get 8. Add 3 and 8 together and you get 11. Okay. Multiply 11 by 2 and you get 22. Add them together, 22. Multiply 2 times 22 and you get 44. Add them together to get 43. Multiply 2 times 43 and you get 86. Okay. Add 0 and 86 together. You get 86. Multiply by 2 and you get 172. 172. Add 172 and 3 together and you get 175. So this thing called the remainder theorem says that whatever the remainder is what g of 2 is. So using this is just a really fancy way of plugging in g of 2. So let's just double check. G of 2 would be 2 times 2 to the 6th power plus 3 times 2 to the 4th power minus 2 squared plus 3. Does anybody have a calculator? Let me pull my calculator. So this is basically 2 to the 7th power. This is 128 plus 3 times 2 to the 4th plus 48 minus 4 plus 3. So if I do all that, 125 plus 48 plus 3 minus 4, I get, oh, did I do something wrong? I get 172. Maybe I'm telling you the wrong thing. Maybe it's actually this number up here. I might have had the wrong thing circled. Hold on, let me double check that. So kind of going back to the theme at the beginning, this is one of those skills that I'm going to teach you that you probably will use the other method because, like I said, I'm just a little bit rusty. So let me double check that. Give me a second. No, it should be the number at the bottom. Did I do something wrong in my adding? It should be the remainder at the bottom. It should be the negative. It should be whatever it is. Maybe I did something wrong in my numbers here. All right, what did I do with that? Let's see. I'm not quite sure what I did wrong with that problem. I'm gonna have to come back to that, guys. But that's the idea. It worked correctly for the other one, so I'm not quite sure what I did for that. I do something wrong with my 2 times 2 to the 6th. Let me look at one more thing. Oh, okay. All right, I feel better. I did something wrong with my math here. I'm not quite sure what I did with my math. So probably something with this line is wrong. But if I type this into Desmos, I get 175. I'm pretty sure that's right. So maybe synthetic division is the easier way to do it. I'm not quite sure. So that's one possible way to solve that. All right. I think I'm going to stop there. I think I want to let you guys try out your homework for that. And then that way on Monday, we'll have like a few more questions to do. But if you've had a chance to try it, then I think that it'll make the last few questions make more sense. So basically for your homework, make sure you do, you're working on 2-1 and 2-2, your test, obviously. And then for 2-3, you can go through number 38 or 37, I guess, in your homework. And then we'll just talk about the rest on Monday and kind of wrap up from there. I just want to give you guys a chance to try it. But that is right. The remainder is whatever the solution is to the polynomial. I just did something wrong in my math there. Okay. Any questions about that? Sound like a plan? Everybody going to try it out? You excited? Synthetic division? Greta said she's so pumped. That's awesome, Greta. Have fun doing that. All right, guys, thanks for coming today, and I will talk to you guys on Monday, all right?
Bye,
Bye, guys.
see you Monday.
Bye. Thanks.